All right, day 2 of 5.1, which is the natural log function differentiation. We're going to use logs to break apart functions and differentiate smaller pieces. So using what we learned yesterday, and then we'll be able to differentiate, a function that is more complicated using natural logs. So if we have y equals x cubed square root of 4x plus 3 all over x plus 6 quantity squared. Okay, now this obviously looks very complicated. So this is where we can actually introduce logs in order to find dy dx. Okay, now you might be thinking, what do you mean introduce logs? So if we take the log of the right side, that means we have to take the log of the left side in order to keep it balanced. So right now we haven't changed it because we took the log of both sides. But now what we're going to do here is we're going to use logs to expand the right side of the equation. So we have natural log of y equals, we'll have 3 natural log of x plus 1/2 the natural log of 4x plus 3. And then we'll have minus, using the quotient rule with logs, 2 natural log of x plus 6. And at this point, this is where we're going to differentiate both sides with respect to x. So we're going to take the derivative of the left. And again, if we do that on the left, we got to do that on the right. So on the left, the derivative of the natural log of y will be 1 over y times dy dx equals, now we're going to go through here and differentiate each piece. So this will give us 3 over x times the derivative of x, which is 1, plus 1/2 times 1 over the argument times the derivative of the argument minus 2 times 1 over the argument times the derivative of the argument. Now remember what we're solving for. We are solving for dy dx, so we do want to get that by itself. So I'm going to simplify on the right before we get that dy dx alone. So on the right we have, what do we have? We have 3 over x. Here, we're going to have 2 over 4x plus 3. Here, we're going to have 2 over x plus 6. That equals dy dx times 1 over y. So now we want to move that 1 over y to the other side by multiplying by the reciprocal. And dy dx equals, notice how you have this y here, okay? We do know what y equals. Go back to the beginning, right? So we're going to plug that in. And then we'll have it times everything in here. And you don't need to distribute. This will be your answer. And so now you found dy dx, the rate of change of y with respect to x. So what we just did, this is called logarithmic differentiation. Okay, so what you do when you use logarithmic differentiation, you introduce the log to make it an easier problem. Okay, so that's it. That's all day 2 is. So notice what you're using. You're using what you learned on day 1. You're using the expansion from logs. Remember how we expanded and condensed in Algebra 2 and in pre-calculus? Putting that all together and then finding the derivative using chain rule and just getting everything to one side to solve for dy dx. All right, that is it. Enjoy your weekend.